Good evening, everyone. Okay, let us start. So we are in Boolean algebra, right? So yesterday, just I had given introduction for Boolean algebra. Anyway, there was some interruption, right? So let us start from the beginning once again. See, what we are going to do now, from this moment onwards, I said, whichever the things that we are going to consider in digital domain, we are going to define the systems or functions. We are going to realize all these things in terms of what? Zeros and ones, right? Okay. So now in this session, we are going to learn, right, some type of gates that we are going to use, some type of basic properties of our functions. And I said, I am going to use some alphanumerical number systems. They are called AB, right? With the help of AB, what I have been told you, this A indirectly denotes either this value might be 0 or this value might be 1. Similarly, when we are looking for B, this B might be 0 or this B might be 1. So based on the combinations, we are going to design different type of systems. That is what I have been told you. And yesterday I have given some other conclusions. We saw AND gate property, OR property, and the NOT properties at all. Anyway, let us repeat all those things once again. Okay, let us start from the beginning, right? Let us go ahead with the OR operation. OR operation is similar as addition. I said, when we are adding two variables, let us start from the beginning. Two variables in the sense, two binary variables. If I have two variables, that is A and B, and I would like to get its correspondent output, right? In that case, I said that is called OR operation. In case of OR operation, this A and B might be, its combination might be 0, 0, or combination might be 0, 1, or combination might be 1, 0, or combination might be 1, 1, such that its correspondent output is going to be, in case of OR operation, 0 plus 1, 0 plus 0 will give you 0, 0 plus 1 will give you 1, 1 plus 0 will give you 1, 1 plus 1 also will give you 1. I said, in case of OR operation, in order to enable your pin, there are two things that we are going to consider in the output side. One is called low pin, another is called high pin, or we can call it as 0. It's also called disable pin. It is also called disable pin. The rest of it is going to be enable pin. If you notice the OR gate carefully, in case of OR gate, at least one input value must be what? High, such that your output is going to be enabled. Getting me? Notice பண்ணி பாருங்க, at least ஏதாச்சும் ஒரு வேல்யூ வந்து 1 இருந்தா கூட அவுட்புட்ல 1 வந்துரும். If both are 1, okay, we are happily we can set the output mode. But the thing is, at least one high input pin should be required in order to set your output value as enable. Clear? So that is all about OR operation. Let us discuss about AND operation. In case of AND operation, what I had been told you, once again, let us take the gates A, B, and its output is, let us consider, that is Y. Now in this case, let us consider four variable combinations 0, 0, 0, 1, 1, 0, 1, 1. In this case, in case of AND, what I have told you, see there, at least, right, at least if one input is disabled, such that output is going to be disabled. In order to obtain AND gate, in case of AND operation, your output is going to be enabled when all your inputs are going to be enabled. Right? Input pin enable, output will be enabled. Otherwise, your output is going to be 0. Clear? So that is called AND gate. So in case of AND gate, if at least one input is disabled, you can consider thousands and thousands of inputs here. For our example, we are taking only two combinations. You can consider ABC, you can consider ABCD, you can consider ABCDE. Like that, you can consider any combinations here. The conclusion is what? The thing is, in any combination, right? If all your inputs are enabled, then your output will be enabled. Otherwise, your output is going to be 0. Next, finally, we are going to discuss about NOT. NOT logic in the sense, see, A, let us take output is Y. If your input is 0, NOT means that is called complementary. This gate is called complementary gate. What do you mean by complementary or complement? The thing is, if your input is 0, then output is the complement of input. Output will become 1. If your input is 1, then output will be the complement of input. Now, so 1 will become 0. Clear? So that is the basic things that we are defining in terms of under or and not operations, right? So these are the basic things that we are realizing from these logic gates, right? Actually, till now we are not going to talk about logic gates now. I am just introducing operations, right? This is OR operation, this is called AND operation, that is called NOT operations, right? So let us see some of the properties of them. Sir, no video. Guys, please tell me, is there any problem in video? Someone said there is no video. Please respond. From my side, I think there is no problem. Is there any problem in class? Please let me know. Say yes or no in the comment box. No sir, video clear. No sir, video is good. Okay, fine. Let's continue. So this is AND OR and NOT operations. Okay, let us continue. Next, let us take some of the properties. What are the properties? Suppose I have a alphanumerical variable A and it will be added with 1. OR operation, I am doing once again OR operation. A plus 1 should be equal to what? A plus 1 அப்படினா see, this A might be 0 or it might be 1. The thing is, see there, let us see the both combinations. If A is 0, first conclusion, if A is 0, then 0 plus 1 will be equals to 1 because we are doing OR operation. In case of OR operation, first let us see some of the properties of OR operation. See 0 plus 1. What I told you, from the input side, if at least one pin will be enabled, then your output will be what? 1. Similarly, suppose this A might be 1. I said it's the alphanumerical number system. It contains both 0 and 1. We should see the possibilities. If it is 0, then what happens? If it is 1, then what happens, right? So if it is 1, then 1 plus 1 is what? 1. See, the conclusion is, if I find any value with 1, in case of OR operation, simply I can say that output is going to be 1 only. See there, A might be 0 or 1, irrespective of the value of A, output is being sent as 1. The conclusion is what? While doing OR operation, what I have told you, if at least one pin is enabled, then your output is always being enabled. That is the basic property. So the conclusion is A plus 1 should be equal to, wait a minute, A plus 1 equal to 1. Similarly, let us take A, let me add it with 0. If A is being added with 0, then what will be the answer? See, either A might be 0 or it might be 1. If A is 0, then 0 plus 0 will give you what? 0. Suppose if A is 1, then 1 plus 0. 1 plus 0 will give you 1. So what is the conclusion here? It is, see there, irrespective of this value, it is following the value of A. If A is 0, then output will become 0. If A is 1, then output will become 1. Such that A plus 0 should be equal to A. That is the second conclusion. Now the third conclusion is, I have A and I am adding it with the A bar. Then what happens? A bar in the sense complement of A. Complement of A. In the sense, suppose let us take, if A is 0, then A bar is how much? If A is 0, A bar in the sense complement of A will give you 1. Suppose if A is 1, then complement of A bar will be 0. Only two possible combinations. If I add these two values, it should be equal to 1. If I add these two values, that should be equal to 1. Since you are doing what? OR operation. Since you are doing OR operation. So what is the conclusion here? 0 plus 1. See, at least one pin is enabled, then output will be enabled now. So A plus A bar will always be equal to 1. That is the next conclusion. I hope things are very clear to you, right? Nothing is there to understand. Very simple, right? Similarly, if I have a term A bar and I am adding it with 1, then what I will get? A bar plus 1 is what? I said, see there, irrespective of anything plus 1 is always equal to 1, irrespective of that variable. Because in our operation, if at least one pin will be enabled, then output will become 1 only. Clear? I think all of you getting clear idea. Clear? Yes. Let us see some of this. Same thing we have to observe in case of under pressure also, right? Under pressure in the sense, just now we have been observed the under pressure. Anyway, let us proceed. In case of under pressure, I have A once again and I am multiplying it by 1. What I get? A dot 1 is equal to what? See, suppose if A is 0, then 0 dot 1 will be equal to 0. Suppose if A is 1, then 1 dot 1 will be equal to 1. Right? So what is the conclusion here? In case of under pressure, see there, it is, if it is 0, then output will become 0. If it is 1, then output will become 1. It's simply following the value of A. So whenever your A is being multiplied by 1, irrespective of the value of 1, it is following the value of A. So A dot 1 will always be equal to A only. Clear? Similarly, suppose if I have A dot 0, then what happens? I said in case of under pressure, right, if any one pin will become 0, one pin 0 irrespective of other pin, output is going to be 0. See, A might be 1 or 0, it does not matter. 1 into 0, 0. 0 into 0, 0. So irrespective of the value of A, whenever your input value is being multiplied by 0 in case of under pressure, output is going to be 0 only. Clear? Let us see. Similarly, I have A dot A bar. Let's see what happens. A dot A bar in the sense, see, suppose if A is 0, then A bar will become what? Suppose if A is 1, then A bar will be 0. What is the conclusion? 0 dot 1, 0. 1 dot 0, 0. So what is the conclusion? A dot A bar is going to be 0. Very important observations. Don't forget, right? So A dot A bar is always going to be equal to 0, right? That's all. These are some of the properties that we are observing in case of R under operation. Clear? Yes. Let me rub these things. Let us slowly enter into the gates, right? And then we will perform the basic things. Now what we are going to do? I said since we are in Boolean algebra. In Boolean algebra, with the help of this alphanumerical number system, first we are going to design the basic switches, and then with the help of these basic switches, we are going to perform the various operations inside the circuit. Right, and we will see how our circuit is being operated with the help of these logic gates, how we are transforming the signal from input side to output side with the help of these binary codes, right? So in order to understand all the switching circuits at all, first we should get the clear idea about the logic gates, right? So keep that in. Now we are going to discuss about the basic fundamental properties of logic gates, and then we will see rest of all things one by one, right? Now we understood some basic properties. Now let us moving on to the next topic, that is called logic gates. Slowly we will learn all these things. Don't be panic, right? So logic gates. In logic gates, there are many combinations. Let us see one by one all those things, right? The first logic gate, that is with the help of logic gates in the sense, logic in the sense we are going to use 0 to 1 binary values. With the help of 0 and binary values, we are going to perform various operations, right? So let us see. The first gate that I am introducing is called NOT gate. NOT gate, people are calling it as complementary gate. That is complementary gate. Why we are calling it as complementary gate? Why we are calling it as complementary? Complementary in the sense from this input side, right? From the input side. For example, listen. The universal representation of the NOT gate is, first we should represent the gate. Let us see. Right? Now, for this gate, if we are input side, in the input side, if I am giving A, then in the output of this gate will become A bar. That is called complementary gate. Guys, listen. Which are the things that we are learning here? We are learning these things in terms of digital. Back side of this circuit, we will have inbuilt. Transistor will perform some specific operations. BJT, MOSFET, NPN transistor. All the people are working based on these logic gates with some microprocessor programs and all, right? Anyway, we are not going to learn those things at all. We are learning digitally what's happening, right? Basic layouts. Clear? Yes. So this is the representation of the NOT gate. If your input is A, then output will become A bar. If your input is 0, then its output will become 1. If your input is 1, then its output is going to be 0. Let us see the truth table of the NOT gate. With the help of this one, let me develop the truth table. Right? So whereas in case of truth table in the sense input versus output characteristics, right? Truth table bring out the characteristics of the that is input output relationship of your logic gate, right? So whereas in the input side we are going to give y, output let us call it as y, right? So input is a, output is going to be y. Let us see what is the possible outputs, right? If your input is 0, then output is going to be 1. If your input is 1, then output is going to be 0. That is the basic explanation of your what I can say truth table of your complementary operation, that is logic gate, right? And see that in case of NOT gate, output y is going to be equal to what? A bar. A bar in the sense input is A, then output will become complement of input. Clear? That is the basic thing that we are learning in case of NOT gate, right? So let me introduce the second gate. Mathematically learn these things once again because it's very easy. Digital is very easy. Just we have to learn the basics. That is enough. Slowly, I will bring out all these concepts and I will register these things in your mind. So the second thing we are going to learn is OR gate. Let us perform OR gate once again. Right? The universal representation of the OR gate. Right? The minimum number of variables that I am going to use are 2, A and B. Right? And the representation of the OR gate is like this. This is how we are representing the OR gate. Right? If your input is A and B, I said OR gate will perform addition operation. It means A and B are being added up together. So your output is going to be A plus B. That is the representation of OR gate, right? Let us see the truth table of the OR gate. Let us see the truth table. So in case of OR gate, I am using 2 input pins minimum. And then you can raise the input number of input pins. It's later. Slowly we will do. First we will learn the basics, right? Input is, we have 2 combinations, alphanumerical number system. It has the combination. Its combination might be 0 0, 0 1, 1 0, 1 1. Its corresponding output. 0 plus 0 will give you what? Since you are performing OR operation. In case of OR operation, what I had been told you, at least one pin, input cycle, at least one pin has to be enabled. Enabled the one, such that your output is going to be enabled. If all the pins are disabled from the input side, output also will be disabled. If it is, see there, one pin is enabled, output is enabled. One pin is enabled, output is enabled. 2 pins are enabled, happily you can set the output as enabled. Clear? So that is the truth table of your OR gate, right? So inputs are A and B, output is Y, such that its output is going to be A plus B. That is how we are bringing out the properties of OR gate. Clear? Yes. Let us learn these things. We have to learn some of the properties, right? Yesterday I taught associative property, distributive property, commutative properties, etc. After completing this logic gates, we will demonstrate all those things because in that way it might be easily understandable by you all. So I thought better going in this way might be let you all to understand, right? Let us talk about AND gate. See, in the universal representation of the AND gate, first just to learn it, that is the representation. It has minimum 2 input pins A and B. And its output, we all know AND will perform the dot operation or cross operation, product, right? So output will be the product of A dot B. That is the operation of AND gate. Let us see. Since we are considering 2 variables at the input port, right? Whereas in the output port, I am going to consider only 1 variable, right? So let us see. When we are performing the AND operation, inputs are going to be 0 0, or it might be 0 1, or it might be 1 0, or it might be 1 1. Right? Whereas when we are performing AND operation, it is going to be the product of inputs. A dot B, 0 into 0 will become 0. We know AND operation at least, right, one input has to be disabled in order to set the output is disabled. ஏதாச்சும் ஒரு இன்புட் டிசேபிள் ஆனா அவுட்புட் என்ன ஆகும் டிசேபிள் அவுட்புட்ல எனேபிள் வரணும் அப்படினா இன்புட் சைடுல நீங்க செட் பண்ற எல்லா பின்னும் எனேபிள் ஆகும் then only in case of AND gate your output will become enabled, output will be enabled. Clear? Yes. So this is the truth table of your AND gate. I think things are clear, right? So let me introduce the next person, that is called NAND gate. First to learn the things, slowly we will learn all these things, right? NAND gate. First thing, what is the universal representation of the NAND gate, right? See, the universal representation of NAND gate is, see that, actually it will be the combination of, NAND gate will be the combination of AND gate plus NOT gate. That is called NAND, right? See there, in the first half we are performing AND operation, and then we have to perform NOT operation, such that what will happen now? See that when I will pass two input here, AND gate enna பண்ணும் exactly at the output port. AND gate is known as the product of input. See that if I pass A and B through the AND gate, output will become the product of A and B. Now we should talk about the NOT gate. NOT gate la enna nadakkum? In the NOT gate, if I pass any input, the input la pass பண்ற value output la enna மாத்திரும்? It will be the complement of the input. Since in the input port NOT gate kulla enter value AB, output la enna varum? AB bar. Just it will take the complement, right? So this gate will be generally represented as whenever ஏதாச்சும் ஒரு இடத்துல நீங்க bubble பாத்தீங்க அப்படினா it means see there this NOT gate will be replaced by a bubble. So whenever you are looking for ஏதாச்சும் ஒரு gate வந்து bubble இருக்கு அப்படினா it means there is a hidden NOT gate. You should think, right? You have to register if there is any bubble with the gate, that bubble denotes there will be a hidden NOT gate. Clear? Yes. Such that if I pass A and B through the NOT gate, output will become A dot B whole bar. Clear? Shall we write the truth table? Yes. Let us write the truth table. AB and inputs are going to be 0 0 0 1 1 0 1 1. What is the difference between AND gate and NAND gate? The difference is in case of AND gate we have AB, whereas in case of NAND gate complement of the AND gate. See there AND gate output ku complement eduthinga appadina you are getting what? NAND gate. See there AND gate output la 0 0 0 1 iruka. If I take complement for this you are getting NAND gate. So the thing is you know listen, let us perform the operation. We all know y is equal to AB whole bar. See that 0 into 0, first we have to perform AND operation and then we have to perform NOT operation. Two operations should be required, right? So first let us perform AND operation. 0 into 0 will give you 0 according to AND operation. 0 into 0 will give you 0. 0 bar will give you 1. 0 into 1 will give you 0. 0 bar will give you 1. 1 into 0 will be 0. 0 bar will be 1. 1 into 1 0. Sorry. In case of AND gate 1 into 1 1. 1 bar 0. Clear? So that is the truth table of your which one? NAND gate, right? I think this box is visible to you all. Yes, that is visible. So that is going to be NAND gate, right? So let us discuss about next one, that is NOR gate, right? So let us try and understand the properties of NOR gate, right? And let me explain one more thing, guys. Listen. This gate can also be drawn in the alternative way at sometimes. Listen, let me draw that one also quickly here itself. Let us consider one OR gate here. Let us consider OR gate. This is OR gate. In the input port, I would like to connect. That is, I would like to connect on bubble. If I put bubble, what do I mean? See, I am passing A and I am passing B here. If A and B in the pass panninga, see there. First, what is the meaning of this bubble? This bubble indicates actually there is an inverter. Correct? There is an inverter. Similarly, this bubble also indicates there is an inverter. அப்படினா மீனிங் என்ன? நீங்க A வை பாஸ் பண்ணீங்க அப்படினா இந்த பபிளை கிராஸ் பண்ணும்போது வேல்யூ என்னவா மாறும்? A பார். இதுவரையே நீங்க B யை பாஸ் பண்ணீங்க அப்படினா இந்த பபிளை கிராஸ் பண்ணும்போது வேல்யூ என்னவா மாறும்? B பார். அப்ப एक्चुअली OR கேட் குள்ள யார் என்ட்ராவா? OR கேட்டுக்கு முன்னாடி we have to perform NOT operation. First in this pin I have to perform NOT operation separately. Here also we have to perform one NOT operation and then you can pass the resultant variable into the OR gate. OR gate என்ன பண்ணும்? OR gate வந்து இன்புட்ல வர வேல்யூவை அப்படியே வெளியில ஆட் பண்ணி கொடுக்கும். கரெக்ட்டா? A bar plus B bar is going to be the output. I know, see, let me introduce you one more person here. The thing is, அப்ப A வந்து இது வழியா பாஸ் பண்ணீங்கன்னா this bubble will take the bar, will complement this A and this bubble will complement this B such that A bar plus B bar will going to be the output of this OR gate. OR gate plus bubble, right? OR gate plus NOT gate will give you A bar plus B bar. Let us introduce this A bar plus B bar can be combined as AB whole bar. That is called De Morgan's law. Slowly you will see the theorems and all. Right, first you have to understand. When you are looking, that is இங்கே நீங்க realize பண்ணீங்கன்னா define பண்ணும்போது ஈஸியா வரும். Right, so the conclusion is A bar plus B bar, that is A bar plus B bar can be written as A dot B whole bar. Right, A dot B. See that A dot B whole bar. Since we are looking for the operation of NAND gate, so what is the conclusion? This circuit will be equal to this circuit, right? So NAND gate can also be realized in terms of NOT gate plus OR gate. Clear? Yes. Now I am looking for NOR gate. Let us design NOR gate. Now when we are trying to design NOR gate, the universal representation of the NOR gate is, once again, first let us denote. See there, NOR gate in the sense OR gate plus NOT gate is going to be the NOR gate. right? So let us see. If I pass A plus B through this gate, OR gate enna பண்ணும்? OR gate will perform addition operation A plus B. What about NOT gate? NOT gate என்ன பண்ணும்? அது வழியா நீங்க பாஸ் பண்ற இன்புட்க்கு காம்ப்ளிமென்ட் எடுத்துரும். A plus B தான் நம்ம அது வழியா பாஸ் பண்றோம். Just it will take complement from that. Whole complement. Clear? Such that this function can also be written as A plus B whole bar can also be written as A bar dot B bar. That is also called another De Morgan's law, right? So that is second law of De Morgan's. So the conclusion is what? A bar plus B bar can be written as A dot B whole bar, right? A plus B whole bar can be written as A bar dot B bar. That is De Morgan's law, right? Anyway, first I will complete this one. So since we are performing what? NOR operation, right? So according to in case of NOR operation, this gate can be realized as, so what have been concluded? So the thing is, this can be redrawn as, you can redraw the circuit as like this, right? If I pass A and B through the NOR gate, then output will become A plus B whole bar. Clear? Yes. Let us see the truth table of these gates A, B. Output is going to be Y. So input is 0, 0, 0, 1, 1, 0, 1, 1. Actually, what is the output here? We know one thing. What we all know, the thing is, when we are looking for output of NOR gate, actually NOR gate will be a combination of OR gate plus NOT gate. First we have to perform the operation of OR gate, and then we have to perform the operation of NOT gate, not gate, right? So let us see. OR gate padi 0 plus 0 will be 0 for OR operation, and then I have to take complement such that output will become 1. Similarly, 0 plus 1 will give you 1 in OR gate. If I take complement, then I will get 0. 1 plus 0 will give you 1 in OR gate. If I take complement, I am getting 0. 1 plus 1 will give you 1. If I take complement, then that will become 0. Clear? So this is the basic truth table of NOR gate. This is the basic truth table of NOR gate. I hope things are clear, right? Let us see how to draw the NOR gate in the alternative way. I said there is one more way. NAND gate you have to draw one way. The same way we can also draw NOR gate. Let us see the another alternative way to draw the NOR gate, right? So NOR gate can be realized as, let us see. Let me take a NAND gate here. Let us take one more NAND gate here, right? And then let me attach it with the AND gate. Let's see what happens. See there, I am passing A here and I am passing B here. We all know what your NAND gate, NOT gate enna pannum? It will take the complement. It will take the complement such that output will become. AND gate enna pannum? It will multiply them, right? So such that output will become A bar dot B bar. Now, according to De Morgan's law, A bar dot B bar can be rewritten as A plus B whole bar. See then, that is the output of NOR gate. So NOR gate can also be realized in terms of AND gate and NOT gate. And I said these NOT gates are simply represented as, we are putting some bubble and then it is AND gate, right? So this is the representation of, right? That is the equivalent circuit of NOR gate. That is the equivalent circuit of NOR gate, and its output is going to be what? A plus B whole bar. Clear? So that is the representation of NOR and NOR gate, right? Now from NAND gate and NOR gate, we have been realized one simple theorem, that is called one simple law. That law is called De Morgan's law, right? Since I'm introducing, right? So here we saw two laws, right? Two theorems. They are called what? De Morgan's law. According to De Morgan's law, if I am having any function A plus B whole bar, that function can be directly written as A bar dot B bar. Similarly, if I have a function A dot B whole bar, then that function can be written as A bar plus B bar. Clear? So that is De Morgan's law, right? So with the help of De Morgan's law, we are realizing NAND gate and NOR gate. And this NAND gate and NOR gate can also be called universal gate. Since NAND gate and NOR gate are called, right? NAND gate and NOR gate. One second. NAND gate and NOR gate are called universal gates. Why they are called universal gates? We all know the reason, right? Many of you might study these things. What do you mean by universal gate? அப்படினா மீனிங் என்ன? NOR gate NAND gate யூஸ் பண்ணி நம்ம எந்த கேட் வேணாலும் டிசைன் பண்ணிக்கலாம். We can design AND gate, OR gate, NOT gate, NAND gate. NAND யூஸ் பண்ணி NOR டிசைன் பண்ணலாம், NOR யூஸ் பண்ணி NAND டிசைன் பண்ணலாம், and then XOR gate, XNOR gate. So all type of logic gates can be realized in terms of NAND and NOR gate, such that NAND gate and NOR gates are called universal gate. அப்படினா மீனிங் என்ன? அப்ப என்கிட்ட NAND gate, NOR gate மட்டும் தான் இருக்கு அப்படினா, with the help of NAND and NOR gate, we can design the entire digital circuit happily. Sir, I don't have NOT gate, I don't have OR gate, I don't have AND gate. I don't want them. Do you have a NAND gate and NOR gate? Just to bring it out. I will design the entire logic circuits with the help of those two people, right? Only with the help of NAND gate மட்டும் வச்சிக்கிட்டே ஒரே ஒரு gate. Even NOR also not required. NAND gate மட்டும் தான் required. That one gate is sufficient to design all digital electronic circuit. And the NOR gate வச்சு நீங்க பாத்தீங்க அப்படினா that one gate is sufficient to design all circuit. But see that though NAND and NOR gates are called universal gate, universally we are giving priority for the NAND gate only. Because the problem with the NOR gate is, in case of NOR gate, we have high switching losses, right? Losses in case of high switching losses in case of NOR gate is high, whereas in NAND gate we have very less amount of switching losses, such that always universally priority will be given for NAND gate. We are not giving priority for NOR gate because of the losses. Practical observation, clear? Yes. So let us coming back. Now we should talk about the next type of gate, that is called the XOR gate. Let me teach you, right? Next we are going to discuss about XOR gate. I will let you all how to design all gates in terms of NAND and NOR immediately after completing gates logics. Okay, we are going to design all these things. First we have to learn the basics for that, right? Yes. So first, now we are moving on to the next type of gate, that they are called special gates, right? See, first NOT gate, AND gate and OR gate, they are simply called basic gates, whereas NAND gate and NOR gate are called universal gates, whereas XOR gate and XNOR gates are called special gates. Okay, let us look at the properties of special gates. In the special gate, first I am introducing XOR gate. We are going to look at the property of XOR gate. Now when we are looking for XOR gate, once again the universal representation of the XOR gate is, it will be represented like this, right? That is the universal representation of XOR gate. Since in the input side we have two variables, one is A, another one is B, whereas output of this function is going to be, it will be represented like this, A XOR of B. Clear, right? See, that is called A XOR of B, and it can be rewritten as, this function can be realized as A XOR of B means, it means, listen guys, it can be rewritten as A bar B plus A B bar. That is the logic that we are following in case of XOR gate. That is the special realization. Don't think too much, right? ஏன்னா டிஜிட்டலை பொறுத்த வரைக்கும் சம்திங் டிஜிட்டலில் வந்து என்ன அப்படின்னா இன்வென்ஷன்லாம் கிடையாது. டிஜிட்டலில் எல்லாமே என்ன அப்படின்னா எதுக்குமே வந்து டேரெக்டாக ப்ரூஃப் இருக்காது. இந்த கேட்ஸ் வந்து ஏன் இந்த மாதிரிலாம் லாஜிக் வருது, இப்போ எர்த்து சுற்றி மேக்னெட்டிக் ஃபீல்டு இருக்குன்னு நம்ம சொல்கிறோம், அது எதனால் வருது, எப்படி அதெல்லாம் பில்ட் ஆச்சுன்னு கேட்டால் நோபடி வில் டெல் யூ தி ஆன்சர் ஃபார் தட் ஒன். ஸோ இன் தி சேம் வே டிஜிட்டல் எலக்ட்ரானிக்ஸை பொறுத்த வரைக்கும் சர்க்யூட்ஸ் வந்து இந்த மாதிரி டிசைன்ஸ் வச்சு காம்பினேஷன் வச்சு டிசைன் பண்ணுறாங்க, அவுட்புட் வந்துருச்சு, வி ஆர் ஹாப்பிலி கோயிங் வித் தட் ஒன். That's all. அது எப்படி வந்தது, அது எதனால வந்திருக்கு, that reason nobody knows the reason for that, right? So in digital I have some logic gates like this. If I am passing A and B, its output will become like this. நான் இந்த மாதிரி டிசைன்ல ஒரு லாஜிக் கேட் டிசைன் பண்றேன், ரைட்? பேக் சைடுல A bar B plus A B bar, right? With back side we have some transistor and diodes logics and all. With the help of them we are happily designing some circuits. It's happening like that without reason. So we are just following. Okay, நடக்குதுல, I want that operation, but I don't know how it is happening, but we are following it. Okay, that is what we are doing in case of digital electronics. So just to learn these things mathematically, that's very important. Okay, anyway, that is XOR gate, and we are realizing its output operation is A bar B plus A B bar. Clear? This is the output of XOR gate. Let us see the truth table of your XOR gate, right? So in case of truth table, so gate வந்து எப்படி represent பண்ணுவாங்க அப்படினா, in case of XOR gate it can be generally represented as minimum 2 inputs. It has minimum 2 inputs. It will be represented like this, right? We will perform if any function, any box, black diagram, it can be generally represented as XOR representation AB, and output is going to be, since you are performing what XOR operation, and its output is going to be what A XOR of B. That is the general representation of your XOR gate. Let us realize its truth table also. AB output is going to be 1, right? Let us rename in the XOR gate. Some other names are there. Let me define it and then I will give that names and all. Then you get the clear idea. Let's see. The thing is, if your input is 0 0, I said if you are going with the 2 alphanumerical number system, then 4 combinations are possible. 0 0, we can realize 0 1, we can realize 1 0, or it may be 1 1. Let us see if both are 0 0. A was 0, B is 0. Now what will be your output? See that since its output is A bar B plus A B bar, correct? A bar B plus A B bar. Let us substitute the values. Since A is 0, A is 0 means 0 bar will give you 1 dot, B is 0 plus since A is 0 dot B bar, B is 0, B bar will give you 1. But the thing is what? 1 into 0, 0. 0 into 1, 0. Output is 0. So what is the conclusion? I am getting 0. Let us discuss about 0 1 operation. If I perform 0 1, second conclusion, let's see. If A is 0, then 0 bar. A bar means we have to take bar for this. That such that I am getting 1. What about B? B is 1. So directly we can substitute 1.1 plus A is 0. So 0 dot B bar. B is 1. B bar is going to be what? B is 1. B bar is going to be 0. Such that 1.1 will become 1 plus 0.0 will become 0. 1 plus 0, that is R operation, will give you 1. So output is going to be 1. Similarly, let us see 1 plus 0. If I am looking for 1 plus 0, 1 plus 0 in the sense, let's see what happened. A is 0, A is 1, right? A to 1 putting 1 bar will become 0 dot. B is how much? B is also 0. 0.0 plus A is 1, yes, A is 1 dot. B bar, B is 0, B bar is 1, such that 0 plus 1 is going to be 1. So output is going to be 1. What about 1 1? If I am giving 1 1, see there, if I give 1, 1 bar will become 0 dot. B is 1 plus A is 1, but B also 1 now, so B bar will become 0, such that 1.0 will become 0 plus 0.1 will become 0, 0 plus 0 will become 0 only. So output is going to be 0, right? From the truth table, in the truth table, what is the observation that you are getting from the truth table? Nothing is there, just இங்க காம்ப்ளிமென்ட் இருந்தது அப்படினா இங்க இருக்க வேல்யூக்கு நீங்க அப்படியே மாத்தி போடணும். 0 இருந்தா காம்ப்ளிமென்ட் எடுக்கும்போது 1 போடணும். 1 இருந்தா காம்ப்ளிமென்ட் எடுக்கும்போது 0 போடணும். அவ்வளவுதான். மத்தபடி இந்த பார்க்கும் வித்அவுட் பார்க்கும் பெருசா டிஃபரன்ஸ் கிடையாது, ரைட்? Anyway, let us continue our operation. The thing is, I understood one thing. Guys, listen. If I have even number of zeros or even number of ones, then output is going to be 0. Suppose if I have odd number of ones or odd number of zeros, I am getting output as 1. Right? Getting me even number of values the output varala. Even number of zeros will give you 0. Even number of ones also 0. The conclusion is even numbers are not giving the output. Only odd numbers are giving output. Odd number means odd number of ones or odd number of zeros are giving the output. Such that this XOR gate can also be called OR gate. It is also called OR gate. Why? Because only for odd number of input we are getting output. Even numbers in the sense 0, 2 zeros are there, output 0. 2 ones are there, output 0. But here odd number of ones are there, output is 1. Odd number of ones are there, output is 1. Right? So the conclusion is what? Odd number of inputs only will give you the value of output, right? For this function, that is called OR gate. And the second thing is, it is also called inequality gate. Inequality, see there, here we have 2 zeros, here we have 2 ones. For this we are not getting any output. But if I have inequality, A is 1, B is 0, I am getting output. A is 1, B is 0, I am getting output. A is 0, B is 1, I am getting output. Inequality, there is no equal values. If A and B are 0, A and B ஒரே வேல்யூவா இருக்கும்போது அவுட்புட் வந்துச்சுனா that is called equality. Suppose A ஓட வேல்யூ வந்து 0 ஆ இருந்து B ஓட வேல்யூ 1 ஆ இருக்கும்போது அவுட்புட் அது that is called inequality, right? So this gate is also called inequality gate. It is also called inequality gate. That is the another name for this one. So that is all about XOR gate. Let us realize the one more gate that is called XNOR gate, right? So the next gate that we are going to realize now is called XNOR gate, right? We are going to realize XNOR gate. Let us see the universal representation of the XNOR gate, right? So let me club them together, right? Once again, XNOR gate in the sense it is the combination of XOR plus we have to consider one NOT gate, right? Let us give the input as A and B, such that what happens, guys, listen. If I consider, right, XOR gate output and if I pass two input A and B, XOR gate will give you A cross B, that is exclusive, right? That is A cross, that is we are getting A XOR with B, and then we are passing this value through the NOT gate, such that output will become A XOR of B whole bar. Because NOT gate purpose and it is always take complement for this, right? Such that if I take complement, we are going to get A XOR of B. It is represented, that is called NOR gate representation. So it will be represented as in the box. If I am putting, if it will be simply represented as, that is the output Y, and this is going to be AB. We are performing XNOR operation, right? So just we are putting dot here. We are performing XNOR operation. Anyway, let us see what is the equivalent value of A XOR of B whole bar. We all know A XOR of B can be written as A bar B plus A B bar. Correct? Guys, listen. Just now we have seen A XOR of B can be written as A bar B plus A B bar. Anyway, here we have whole bar. One more whole bar, right? But we know one more thing. இப்போதான் நம்ம என்ன கத்துக்கிறோம் De Morgan's law. According to De Morgan's law, if I have a function like this a plus b whole bar, that function can be written as a bar dot b bar. Can we write like this? Exactly, that is true. In the same way, see that I am treating this whole value as a, I am treating this whole value as b. அப்ப இது எப்படி எழுதுறீங்க? A plus b whole bar can be written as a bar dot b bar. Is that a mistake? No. In the same way, just I am realizing this one. But let us reduce this function further. Let us reduce this function further. So let me rub these things now. Slowly we will realize all those things, right? Let us continue. I'll apply De Morgan's law. Once again, if I apply De Morgan's law for those functions, I am going to get. Let us complete, right? Once again, if we apply De Morgan's law for this function, what we are getting, actually we got a bar dot b whole bar dot a dot b bar whole bar. Correct? Now we know, according to De Morgan's law, a dot b whole bar can be realized as a bar plus b bar. Do you agree? Yes. A dot b whole bar can be written as a bar plus b bar. Similarly, a plus b whole bar can be written as a bar dot b bar. In that way, this function can be rewritten as, see there, a dot b whole bar. அப்ப இது எப்படி எழுதலாம்? A bar, already a க்கு ஒரு bar இருக்கா? Now according to De Morgan's law, we are going to get one more bar dot, right? Sorry, we have to put plus, right? Plus or b is there, we should consider b bar. Guys, listen. A dot b whole bar can be written as a bar plus b bar. இங்க already a க்கு bar இருக்கு இல்லையா? அப்ப நீங்க De Morgan's law apply பண்ணும்போது you are getting double bar. Anyway, double bar getting cancelled, right? So the conclusion is actually here. The next property is, listen, a bar. If I take a bar, right? for a, if you are taking complement, you are going to get a bar. Again, for a bar, if I take one more complement, a double bar should be equal to a only, because double bar getting cancelled. Clear? Bar getting cancelled. Again, a double bar equal to a. So the next property is a double bar should be equal to a. According to the property, let us see. A double bar can be written as a. Similarly, so let me remove that. Here, see that. Can we apply De Morgan's law here also? Why not? If I apply De Morgan's law, you will get a bar plus b double bar. Do you agree? Yes. Already b க்கு ஒரு bar இருக்கா? If you apply De Morgan's law, you get one more bar such that double bar getting cancelled. So now let us take inner product. ரெண்டு பேரும் மல்டிப்ளை பண்ணுங்க. If I multiply them, then I will get a dot a bar will become, first I am going to get a dot a bar plus normal multiplication, and then it will become what? A will be multiplied with b. Similarly, a bar b bar, we are going to get a bar b bar plus we are going to get ab. Clear? Now, I made mistake here. Listen guys, a bar b bar, and then we should consider b dot b bar, right? Yes, I left this one. Shall we continue? Listen, what is the value of a dot a bar? 0. B dot b bar? 0. We know, just now we saw the AND operation, that is multiplication property. From this I understood it is equal to what? AB plus a bar b bar. So the conclusion is what? Exclusive, that is XNOR gate can be realized as, let us see, the universal representation. This NOT gate can be replaced by a bubble, right? Simple bubble, such that this is going to be input A and input B, and output Y is going to be what? A X NOR of B, and it can be, it is equal to AB plus a bar b bar. That is the actual output of XNOR gate, right? Let us realize its truth table. Let me know these things. Now, what will be its truth table? Its truth table is going to be, since we are considering two input variable a b, output is going to be y. Yes. So input, we may have four combinations 0 0 0 1 1 0 1 1, such that if I take this function, shall we check? 0 0. If both are 0, 0 into 0 will become 0 plus 0 bar will become 1 dot 1. Getting me? Here we have 0 0. Here we have a bar dot b bar. 0 bar will become 1 dot, 0 bar will become 1. So see there, 0, 1 dot 1 will become 1 only. 0 plus 1 equal to 1. So what is the conclusion? Output is going to be 1 for even number of zeros. right? Similarly, when we are looking for second one, so let me rub this one first, right? When we are looking for 0 1 combination, let us see 0.1. 0.1 will be 0 plus second case. Here now a bar dot b bar. A க்கு bar எடுத்தீங்கன்னா we are getting 1. B is 1 na B க்கு bar எடுத்தீங்கன்னா we are getting 0. So 0 into 1 plus 1 into 0. That is 0 plus 0 will become 0 such that output will become 0. What about 1 plus 0? If I substitute 1 and 0, see there 1 into 0 will be 0. And here we are going to take a bar. 1 will be there, 1 bar will become 0. So 0 into 0, that is 0 into, if you bar will become 1 bar. So 0 into 1 will become once again 0 only. Anyway, output is going to be 0. What about 1 1? Let us see. 1 1 in the sense 1 into 1 will become 1 plus 1 bar into 1 bar will become 0. Anyway, 1 plus 0 is going to be 1. Did you notice? Yes. Even number of ones and even number of zeros are giving the output here, such that XOR gate is also called what? Even gate. And the second thing is, whenever A and B are going to be equal, I am getting outputs. Whenever A and B are going to be equal, I am getting output. Right, output as 1, such that it is also called, even gate, or it is also called equality gate. It is also called equality gate. That is the another two names for your XNOR gate. Clear? So this is all about XNOR operation. I hope things are very clear to you all. Right? So basically, we have been realized. Right? How many gates for though? NOT gate, NOR gate, AND gate, NAND gate, NOR gate, sorry, first NOT gate, OR gate, AND gate, NAND gate, NOR gate, XOR gate, XNOR gate, right? So we have been realized 7 gates, right? So totally we have been realized 7 gates. Now, out of those 7 gates, out of these 7 gates, right? I said something. What I have been told you, the thing is, basic gates are called NOT and OR are called basic gates. NAND and NOR are called universal gates. XOR and XNOR are called special gates. They are called what? Special gates, right? Now, what is the relation between XOR and XNOR? Just now we have been realized. So, whenever we are looking for XOR and XNOR gate at the meaning XOR will complement everything. We are getting what? XNOR gate. Whenever we are taking complement for XOR gate, that will give you the value of XNOR gate, right? So, what will be the conclusion here? The conclusion is, next thing, we should realize the thing is, if we have odd number of inputs, then what will happen in the output side? If we have even number of inputs, then what will happen in the output side? That things we have to realize. The thing is, see, we saw XOR gate. If I take A exclusive of B, if you can complement everything, that should be equal to what? A XNOR of B. Yes, this is XOR gate. If I take complement for this, I am getting what? A XNOR of B. Exactly, that is true. Similarly, if I increase the number of inputs as A XOR of B, XOR of C, XOR of D, then that will be equal to, exactly that will give you A XNOR of B, XNOR of C, XNOR of D. So I understood one thing here. What I have understood, whenever your inputs are going to be even numbers, input level number, we are considering 2 alphanumerical number system in the input side. Whenever I am taking complement in case of XOR gate with 2 input alphanumerical number system, that is called even number. A and B are being two number, that is even number. A, B, C, D, 4 numbers are there, that is also called even number. 4 is even number. How many alphanumerical number systems are there? 4 systems are there. So if I take with the even number, if I take complement, that is complement everything, right? XOR gate even number of input consider பண்ணி அதுக்கு நீங்க complement எடுத்தீங்கன்னா that will give you the value of XNOR gate. That is the property number 1. Second case, if I will consider, suppose I am taking A XOR of B XOR of C without complement, it will be equal to the value of A XNOR of B XNOR of C. If I consider odd number of gates for your XOR gate, if you are considering odd number of gates, that should be equal to XNOR. Or I can say, in case of XNOR gate, if your input number system has 3 number or 3 alphanumerical number system, then XNOR and XOR are going to perform same operation. Clear? Suppose if I consider A XOR of B XOR of C XOR of D XOR of E, how many numbers are there? 5 number. Is it odd or not? Yes, odd number. In case of odd number, NOR gate, that is XOR and XNOR, will visualize it. That is, they are realizing the same operation. There is no difference between them. Very important operation. Many of you guys are not knowing these things. Because of that, you people are making blunder mistake, right? Because you will be tested for some worthless 2 more questions. Because people are not knowing these properties. Without knowing that things, they are doing some blah blah things. Finally, they put some wrong answer. If you remember this one, just after reading the question, you can put the answer. Right? So just do remember, if you have even number of gates, even number of inputs, XOR gate, you that is universal. A XOR of that is C. Listen, if you can complement anything, that will give you the value of what? A XOR of B. They are vice versa. Similarly here. XNOR நீங்க கன்சிடர் பண்ணா சரி XOR கன்சிடர் பண்ணா சரி இன்புட் சைடுல ஆட் நம்பர் ஆஃப் இன்புட் இருந்ததுனா XOR XNOR சேம் கேட் தான் there is no difference between them so I can say XOR and XNOR will perform same operation here whereas here if I have XOR if you want to get XNOR then you have to take complement for that suppose if you have XNOR then you should take complement in order to obtain the value of XOR operation. Right? Should try to notice these things. They are very important property of your special gates. Okay. Let us rub these things. Now, let's try and understand some other properties of your NAND gate and NOR gate. See, I said these two people are called special gates. Now there are 2 more gates, NAND and NOR gate. Why they are being called as NAND universal gates? அவங்க ரெண்டு பேருக்கு நம்ம universal gate னு பேர் வச்சோம். I told you the reason without proof. Shall we prove it? Yes. Let's take NAND gate. So the basic operation of NAND gates are known to us. Let us consider NAND first and then we will consider NOR gate. Let us consider NAND. In case of NAND gate, we have 2 inputs minimum, right? Let us consider. And this is the representation of NAND. If I pass AB through the NAND gate, then output will become A dot B whole bar. Clear? I understood. Now within the self of this NAND gate, actually we are looking for 7 gates, right? NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate. Now we have to visualize these 7 gates with the help of this NAND gate. Sir, 7 gate and NAND gate are you might think some other 6 gates. Okay, you can take. And just to consider itself, I am treating this one also gate only, na? Yes. Let's see. NAND gate picture. First, let us design NOT gate. Right? NOT gate and வேணும். Right? NOT gate and NAND gate வச்சு replace பண்ணலாம். See, generally NAND gate எப்படி நம்ம யூஸ் பண்ணுவோம்? See, this is the NAND gate. ஆனா இந்த NAND gate யாரோட அவுட்புட்டை நம்ம ப்ரொடியூஸ் பண்ணோம் அப்படினா NOT கேட்டோட அவுட்புட்டை ப்ரொடியூஸ் பண்ணுவோம். Usually, what is the output of NOT gate? NOT gate ஓட அவுட்புட் என்ன அப்படினா this is the representation of NOT gate. Input side நீங்க A வை பாஸ் பண்ணீங்கன்னா output will become complement of input. That is the output of NOT gate. I have to get the same result from NAND gate. How will you get this one? See there. Let me join these 2 input pins and then combinedly let us give A as the input such that output will become என்ன பண்ணும் இந்த pin வழியா வர வேல்யூ A dot இந்த pin வழியா வர வேல்யூ A dot A dot A whole bar எடுக்கும். See that here we have 2 separate inputs so I put A dot B but here I have same input now so I have to give A dot A whole bar only. Now tell me what is the value of A dot A first. See there if A dot A should be equal to A only. You can visualize A dot A should be equal to A. How it is possible? See, if A is 0, A is 0, but 0 will become 0. If A is 1, 1 dot 1 will become 1 only. Na? So, A dot A will be equal to A only. Right? So, the conclusion is A dot A equal to A, that can be written as A bar. These things can be visualized as A bar. That is the next property. Right? So, here, what I have been proved, A dot A should be equal to A. That is the property that we understood next. Right? Since A dot A is equal to A. Okay, slowly I will insert the properties right at some points in order to let these things to register in your mind. I can separately keep them. Properties in student but some of you might not getting the idea while developing these things. Right? That's why I did not written these things in the property. Fine. Let's continue. This is NOT operation. Yes, it is over. Next we have to perform AND operation. Let us perform AND operation. See, basically we know one thing. AND operation input side we are passing A and B such that output will become A dot B. Clear? That is the basic of AND gate. Now I have to visualize the same thing from NAND gate. Shall we start? Yes. Let us start. Once again, I will take NAND gate here and just observing the output of NAND gate. If I have A and B here, output is becoming what? A dot B whole bar now. I'm just thinking, right? I'm just sitting and thinking. எனக்கு என்ன வேணும்னா இந்த அவுட்புட் வரணும். So what I have to do? I am considering இத நான் திரும்ப என்ன பண்றேன்னா இது ஒரே ஒரு இன்புட்டா கன்சிடர் பண்ணி I am inserting, I am bringing one more NAND gate here. இப்போ என்ன நடக்கும்? See there, this A dot B whole bar இங்கேயும் போகும், this A dot B whole bar இங்கேயும் போகும். கரெக்ட்டா? Such that output will become என்ன வரும்? See there, it will become AB whole bar dot AB whole bar. Is there any mistake? Is there any mistake in my calculation? No. இங்கே நமக்கு என்ன வரும்? A dot B whole bar. Here also we are getting A dot B whole bar. Now only we are to visualize. A dot A should be equal to A only. It means A dot B whole bar dot A dot B whole bar will become AB bar only. But in the top we have one more bar now, so double bar getting cancelled. Output will become AB. Can you getting me? A dot B whole bar dot A dot B whole bar can be written as A dot B whole bar. Whereas on the top of this bar we have one more bar, double bar getting cancelled because we know one more property. A double bar equal to what? A only na? Already we have to visualize this one. So with the help of these two properties, I understood output is going to be AB only. So the conclusion is, if you want to design or if you want to visualize the effect of the AND gate with the help of NAND gate, I may need of minimum 2 NAND gates should be required in order to visualize the AND gate. Just let me keep them, right? So to design NAND gate, I may need of 1 NAND gate. If you want to design AND gate, right? In order to design the AND gate, I may need of 2 NAND gate, right? So let us continue our operation. Next we are going to design. That is, next we are going to perform our operation. Shall we perform somewhere here? Yes, because we have space. Let us perform NOR operation somewhere here. If you want to perform the NOR operation, we know basically NOR operation is output and if your input is A and B, output is going to be A plus B. That is the NOR operation. Exactly, right? So now I have to visualize the same thing with the help of logic gates, right? So let us continue our operation. Since I have, right? என்கிட்ட என்ன இருக்கு அப்படினா I have only NAND gate. I have only NAND gate. NAND gate வச்சு தான் I have to visualize these things, right? With the help of NAND gate only, I have to visualize these things. Now we should think at which way we can bring out the answer for these things, right? At which way we can bring out the answer for these things, right? I am just thinking in order to bring out the answer. Anyway, my conclusion, I may need of A plus B whole bar. A plus B whole bar வந்தா தான் we will get the answer, right? So A plus B தான் வரும். Output என்ன வரும் அப்படினா A plus B தான் வரும், right? So I am just thinking, I don't know what to do, right? So let us see, because I don't know what to do, I am just designing something, right? Because on the paper we have to visualize. சார் இதெல்லாம் இப்படி தான் வருது. நம்ம செக் பண்ணி பார்க்குறோம். நம்ம டிஃபரெண்ட் லாஜிக் கேட்ஸை போட்டு செக் பண்ணி பார்த்தா நமக்கு அவுட்புட் என்ன வருது நமக்கு தெரியும். ஜஸ்ட் பேப்பரில் உட்காந்து நீங்கள் ட்ரை பண்ணி பார்க்க வேண்டியதான். இதில் வந்து ஏன் சார் இப்படி தான் கொண்டு வந்தாங்க, நாட் லைக் தட். இப்படி டிசைன் பண்ணி பார்த்தா ஆன்சர் வந்துருச்சு, அப்படியே எடுத்துக்கிட்டாங்க, அவ்வளோதான், ரைட்? தட் இஸ் தி பியூட்டி ஆஃப் டிஜிட்டல் சிஸ்டம். யூ டோன்ட் நீட் டு அனலைஸ் எனிதிங் ஹியர். இட்ஸ் நாட் லைக் அவர் எலக்ட்ரிக்கல் மெஷின்ஸ். எஸ், லெட்ஸ் see, let us continue. If I have something like this, right? Let's see what happens. I don't know whether that is correct or not. I'm just thinking like that, right? So let's see. It is going to be A bar. See, what will you get here? Here we are going to get A. Here also we are going to get A. Such that its output is going to be what? Output la உங்களுக்கு என்ன வரும்? A dot A whole bar வரும். Such that you are going to get what? A dot A will become once again A only, so it can be written as A bar. In the same way, B is going here also. So B dot B whole bar will become B bar only. Again, I am visualizing. You ரெண்டு பேரும் நீங்க இந்த கேட் வழியா பாஸ் பண்ணீங்க அப்படினா output will become what? So output is going to be A bar once again dot B bar whole bar. Is that a mistake? No, because here I am passing A bar. Here I am passing B bar. So A bar dot B bar whole bar. That is output என்ன வரும்? நீங்க பாஸ் பண்ற ரெண்டு இன்புட்க்கு whole complement எடுக்கணும். That is the output of what? NAND gate. Such that, see there, according to De Morgan's law, this function can be written as. Let us visualize De Morgan's law for the function. What is the answer here? A dot B whole bar can be written as A bar plus B bar. That is the De Morgan's law. Let's prove it. அப்ப என்ன வரும்? A dot B whole bar can be written as A bar plus B bar. Actually, instead of having AB, I have A bar B bar, na? So our bars are available. So they are going to be cancelled each other. What is the output now? We are getting A plus B. So what is the conclusion? If you want to realize NOR gate, at least I will need of 3 NAND gate. If you want to, sorry, not NOR gate, OR gate. If you want to realize OR gate, at least I will need of 3 NAND gate in order to visualize the effect of NOR gate, sorry, OR gate. I'm repeating once again, that is OR gate. Now, what is our next calculation? Okay, now we are design NOT gate, AND gate, NOR gate at all. In the same way, we have to design, right? So let us design NAND gate and what I can say, NOR gate, right? Anyway, NAND gate ku neenga edho design pannona idhu NAND gate. So idu neenga appadiye realize panikalam. Let us design NOR gate, right? Directly let us moving on to the next gate, that is called NOR gate. If you want to design NOR gate, actually what is the output of NOR gate? Let us first write the function NOR gate, because I do never memorize these things. By practice you can apply circuit directly. We should think like this. In the mari panna output vandruma, just neenga apply yosidreenaale you will get the answer. By practice it will become, right? It automatically fall in place. Okay, NOR gate, we are visualizing NOR gate in the sense its output is going to be, see there, whenever I am passing A and B through the NOR gate, actually what happened, your NOR gates will do like this. It is the complement of OR gate. Now OR gate is the complement, we are getting NOR gate, we can visualize these things. Exactly, that is true, right? Now did you notice to one thing, in the three gates which visualize பண்ணும்போது நமக்கு output என்ன வந்திருக்கு பாருங்க, we are getting the output of OR gate. Yes or no, do you agree? இப்போ இது அப்படியே இன்னொரு NAND gate வழியா பாஸ் பண்ணா என்ன ஆகும், செக் பண்ணி பார்த்தோமா? Yes, let me take the same circuit. I am just thinking, இப்போதான் எனக்கு மைண்ட்ல வருது. That is because there are no big things to analyze in digital, right? By practice it will become easy, very easy, right? Let's see, when we are visualizing, இப்போ எனக்கு என்ன வந்திருக்கு அப்படின்னா, I have, இப்போ இந்த மாதிரி ரெண்டு கேட் எடுத்துக்கிட்டா, if I am passing it right through the one more NAND gate, and then இங்க இருந்து ஒரு அவுட்புட் நான் என்ன பண்றேன் அப்படின்னா திரும்ப நான் இன்னொரு கேட் வழியா பாஸ் பண்றேன். இது அவுட்புட் என்ன அப்படிங்கறத நான் கேக்குறேன், ரைட்? செக் பண்ணிடலாமா? This is A, this is B. See that here also we are passing A, here also we are passing A, such that it is become A dot A whole bar. A dot A whole bar should be equal to A bar. Similarly, here also I am passing B, here also I am passing B, such that B dot B whole bar will become equal to the value of B bar. Now here I am passing A bar, here I am passing B bar, such that at this point I am going to get A bar dot B bar whole bar, and this function can be visualized as A plus B according to De Morgan's law. Now this A plus B will be passed through this one and will be passed to this one also, such that output will become A plus B dot A plus B whole bar, such that I know A dot A will become A only, right? We know the property. So A plus B into A plus B will become A plus B only. So its answer is going to be A plus B whole bar. So A plus B whole bar is known as the output of NOR gate. So if you want to obtain NOR gate, so at least, right? So if you want to realize NOR gate in terms of NAND gates, at least I will need of 4 NAND gates. So with the help of 4 NAND gate, we can visualize the effect of NOR gate. I hope things are very clear to you all, right? So should try to keep these things, because the number of gates example you will be tested for some worthless one mark question. Simple kepanga, identify the number of, that is visualize, right, or realize the number of NAND gates required to design the OR gate, number of NAND gates required to design the NOR gate. Like that you will be tested with some chilly questions, right? So do remember all those things. Let's see, next we are going to design the special gates. Now we are going to visualize these special gates. So for that, let me rub these things. Special gates in the sense we are going to design XOR gate under XNOR gates. Let us design XOR under XNOR gates. First, let us take once again. Now our next target is we have to achieve XOR gate. XOR gate, we know the basic of XOR gate. Basically, the universal representation of the XOR gate is this one. And if I am giving input as AB, then output of the XOR gate is being visualized as A bar B plus B bar A, correct? That is the output of XOR gate. Now I have to visualize the same thing with the help of whom? NAND gate. Yes. Let's start our journey with the NAND gate. So let me consider NAND gate here. Let me consider NAND gate here. Let us see if you want to design. But NAND gate we are going to visualize XOR gate. Let's see. For that I am just thinking, right? I am taking one NAND gate here. Let us take one NAND gate here, right? And let us take this input here, right? Let us take this input also here, right? And let us take this input also here, right? Yes. Now here we are giving this into next NAND gate, and we are giving this one into next NAND gate. such that output is can be visualized as. Once again, it is going like this. Slowly understand, right? So it is going like this, and here we are going to visualize one more NAND gate, right? What I am doing, I don't know. Just we have to check the output, right? So let us see what happens here. Right now, in order to get the output, let's see. And here I am going to give A. Here I am going to give B. Shall we? Let us see what is happening. What is the output of this first NAND gate? We are going to get A dot B whole bar. This is the output of first NAND gate. Whereas this A will go here. This A will also go here. This B will go here, right? Here also we are going to get B. Such that output of this NAND gate. Down here, if the NAND gate input of this A dot B whole bar will go here, as well as it will also go here. Clear? So the conclusion is what? A dot B whole bar dot A is going to be. This output is going to be A dot B whole bar. Is there any mistake? No. Here in this point I am giving in the input of A dot B whole bar. Out India input of A such that NAND gate work and the input variable to whole bar. So here in this case I am getting A dot B bar. Here I am getting A. So A dot B bar whole bar is the output of this NAND gate. If you realize the same thing here, this output is going to be B dot A dot B bar whole bar. Clear? So this is the output of this gate. Now let us see. Let us reduce this one. Now according to De Morgan's law, right? Let us see. Guys, listen. Slowly I will reduce. A dot B whole bar can be written as A bar plus B bar. Is there any mistake? No. Let us reduce this function further. It can be further written as, if you open up the bracket, then it is become A dot A bar plus A dot B bar. Right? If you realize these things, let us continue. Which is, see that A dot A bar will become 0. Do you remember? Yes. So 0 plus A dot B whole bar will become, once again, it is become what? A dot B bar only. Again, if I will reduce this function further, then what I am going to get? Actually, according to De Morgan's law, this function can be further written as, then you variable the law, A dot B whole bar can be visualized as A bar plus B bar. Already for B we have one more bar, so it will become B double bar, such that it will be cancelled. So finally we are going to get A bar plus B. The output is going to be what? It is A bar plus B. Similarly, if you are looking for this function, if this function will give you A bar plus B, then this function will give you A plus B bar. Just opposite to this one. You can test it. Now you can try it by yourself, because instead of having A, here I am having B. That's all. So if you reduce this function, here it will give you what? A plus B whole bar. Now let us see. I know this input also. If I pass these two functions as the input for this NAND gate, finally we can visualize it is going to be A bar plus B into A plus B bar. If I open up the brackets for this function, what we are going to get? A bar dot A will become, that is A dot A bar plus A bar B bar. We are going to get A bar B bar plus, right? What we are going to get? We are going to multiply these two things. We are going to get what? AB. Yes. And multiply these two things. We are going to get plus B dot B bar. Right? Now what I will get here? A dot A bar is going to be 0. B dot B bar is going to be 0. So what I will understood here? The thing I have understood here is what? A bar B bar plus AB. Actually, what is the output? Again I am getting what? Here I am getting A bar B bar plus AB. But what is I am in need? See, actually I am in need of XOR gate. What is the XOR gate output? XOR gate. If you want to know the value of XOR gate output, then see there. Now we have to pass this input. Let me rub this one. Okay. Now we have been realized, right? All these things. Now we have been passed this output to the one more gate, right? So let us see. I am considering one more NAND gate here, such that we are going to get yes. So finally, if I pass this one to this one, see, actually this output is going to be A bar B bar plus AB whole bar. Correct? Actually I know 2 times into, again you are going to get same thing only now. A bar B bar plus AB only, but the product will become, let's see there, A dot plus A will become A only now. See there, we are passing same thing to these both of this input. So output is going to be equal to what? A dot A will become 1 only, sorry, A only, such that it will be equal to A bar B bar plus AB whole bar. It should be equal to what? If you reduce this function, once again it will become A bar B plus A B bar. Because we all know right? Complement of X NOR gate will give you X OR gate. It is the output of whom? X NOR gate, right? இங்க நீங்க visualize பண்றீங்களா இந்த இடத்துல நமக்கு கிடைச்சிருக்கு. It is the output of X NOR gate. If I take complement for X NOR, we are getting X OR gate. So what is the conclusion? If you want to design, in order to design the X OR gate, I am in need of 5 NAND gate. If you want to design X NOR gate, I am in need of 4 NAND gates. It's over. So the next conclusion, in order to design X OR gate, I am in need of 5 gates. In order to design X NOR gate, I am in need of 4 gates. Things are over. Yes. So with the help of NAND gates, we are going to complete it. That is, we design NAND gate, NOR gate, OR gate, NOR, XOR, everything is over. Now we have to do the same thing with the help of whom? NOR gate, right? Let us realize the same things with the help of NOR gates. Let's see what happens, right? So let us rub these things. This is all about NAND gate. Now we have to visualize the same thing with the help of NOR gate. Let us take NOR gate. First we all know the generalized representation of the NOR gate. Here we are considering a bubble. If I pass A and B, then the output will become A plus B whole bar. That is the output of NOR gate, right? Okay. Let us visualize NOT gate with the help of NOR gate. Once again, we all know NOT gate na meaning enna? NOT gate in the sense I have to provide, if I am giving input as A, output will become A bar. That is NOT gate. Yes. Let us perform the same operation with the help of NOR gate. Let us take the NOR gate here. Yes. Let us club them. Now I will join these two terminals once again. It is going to be A, such that output will become what? Either A or either A. So when you know A plus A whole bar will become what? Now the thing is, see, A plus A or value in the next property is, if A is 0, then 0 plus 0 will become 0. If A is 1, then 1 plus 1 will become 1 only, such that A will any value கொடுக்குறீங்களோ அதுதான் output வருது. So A plus A also equal to A only. So it is equal to what? A bar. That is the next property, right? So slowly I am introducing the properties just to put it into the box, because they want to register these things, right? Fine. Fine. This is going to be NOT gate. Let us realize next. Shall we take AND gate? Okay. Whichever the things that you want, we can take. It's up to you only. That is, it's up to us, right? Okay. Let us proceed. Better I will do one thing. First I will take OR gate and then we will take AND gate. Later you will understand why I am taking these things, right? Okay. Let us see. In case of OR gate, if I am if I am passing this one, see, if I take A and B here, right? Let us consider one more thing. Yes, I think, yeah. Let us see the output of this one. If I not see there, A will be into the NOR gate வழியா pass பண்ணீங்கன்னா, here we are going to get A plus B whole bar. Do you agree? Yes. Now again I am passing this person through these two inputs, such that output its output is going to be A plus B whole bar plus A plus B whole bar. Clear? But just now we have been realized one thing. What we have been realized? A plus A equal to A only, na? So A plus B whole bar plus A plus B whole bar should be equal to A plus B bar only. See there, in the person ku mela or bar irukka, on the top we have one more bar, so double bar getting cancelled. Finally we are going to get A plus B only. It is the output of whom? OR gate. Since we are realizing OR gate only, na, so output of OR gate is A plus B only. That is what I am getting. How many gates should be required? Let us write. In order to design the NOT gate in terms of NOR gate, I am in need of one NOR gate. In order to design OR gate, right? I am realizing OR gate in terms of NOR gate, I am in need of two OR gates. Let us design AND gate, right? Let us design AND gate. Yes, let me rub these things. Let us design AND gate. Now, when we are looking for AND gate, we all know AND gate na meaning we know the representation of AND gate is, if I pass two input A B, output is going to be A dot B. Yes, that is AND gate, right? Such that if you want to realize these things in terms of, right, NOR gate, we are going up with the NOR gate. Shall we start our journey? Yes. Let's see what happened, right? So let us consider one gate here, right? Listen, these are all standard things, right? And by practice it will become very easy, Nothing is there in digital, it's like a game, right? Yes, let us visualize these things. Let's see what happened, right? I don't know what type of output I am going to get, but I think it is correct, right? My logic. If it is A, it is B. And what about this output? Since it is what? NOR gate. Its output is what? Here also we are giving A. Here also we are giving A, such that A plus A, it will take complement. But what we know, just now we have been realizing the property A plus A should be equal to what? A only. Such that I can say A plus A is equal to A only. So this function can be simply written as A bar. Similarly, if I consider this one, it is going to be B. Here also B. So output will become B plus B. Let us consider B bar such that it can be realized as B. So that is going to be B bar. Now what will be the conversion here? This is going to be A bar. This is going to be B bar. Once again, so here through this we are passing A bar and here I am passing B bar. So output is what? Since it is what? NOR gate. என்ன பண்ணோம்? First input ல இருந்து வர value add பண்ணும். A bar வந்து B bar வந்து add பண்ணிட்டு it will take complement. Because that is the output of NOR gate. Now let us see. According to De Morgan's law, A plus B whole bar can be written as A bar plus B bar. Getting me? B in place of B I have B bar. In place of A I have A bar. So A plus B whole bar can be written as A bar plus B bar only. So there we have double bar. They are getting cancelled each other. Such that we can visualize what I am getting here. Is there a mistake that I made? Yes. See there I am putting dot. Sorry, I am putting plus instead of dot. Right? What is De Morgan's law? We know A plus B whole bar should be equal to what? A bar dot B bar. I put plus. That is wrong. Okay, fine. Let us see. So what we have understood, find I am getting A dot B. So the conclusion is what? In case of AND gate, if you want to design AND gate with the help of NOR gate, I may need of 3, right? So when I am designing AND gate with the help of NOR gate, we can visualize AND gate with the help of NOR gate. 3 NOR gates should be required in order to design AND gate. Now let us design, right? So our next task is, see, if you want to design, next we have to design NOR gate வச்சு தான் நம்ம gates realize பண்ணிட்டு இருக்கோம். So NOR gate does not require anything. So next we have to design the special gates. Let us visualize XOR and XNOR gates. Let us visualize XOR and XNOR gates. Now let me design XOR gate, right? If you want to design XOR gate, once again we will take the same type of structures, right? Let us visualize. Let me take one NOR gate here. Yes. Let us take one more combo here, right? Yes. Let us take one more combo. So here, wait 1 second. It can be written as what? So I can draw the circuit like this. This circuit we can draw like this. And then let us bring these things together. Yes, and let me join them again. Let us continue the operation. Let's see. We will output another part and then you will see rest of things, because I too don't know complete manner of telling, right? So let us see A, B. Let's see what is the output of this one. It is going to be, since it is what? X, it is NOR gate, right? NOR gate output is what? A plus B whole bar. And here we are injecting A, and here we are injecting B, such that its output is what? NOR gate என்ன பண்ணும், இன்புட்ல வர வேல்யூஸ், see here A is coming plus here A plus B whole bar is coming. அவங்க ரெண்டு பேரும் ஆட் பண்ணி it will take whole bar. Similarly here A plus B whole bar is coming. Yes, plus here B is coming. ரெண்டு பேரும் ஆட் பண்ணிட்டு it will take whole bar. Let us reduce. According to De Morgan's law, this function can be written as A plus B whole bar can be written as A bar dot B bar. Now let me introduce the next property, that is called distribution theorem, right? So let us write distribution theorem, right? Already yesterday I had just talked about this distribution theorem, right? I hope you all remember what I had told you. See that if I have a function A plus BC, then this function can be visualized as A plus B into A plus C. The combination is A plus B into A plus C. That is called distribution theorem. I hope that things are visible to you all. Right, so whether the class is going or not. Oh, I am in class only. It shows me it's turned off, right? Sorry for the inconvenience. Yes, that portion is visible. Let's continue. This is distribution theorem, right? With the help of distribution theorem, if I apply this theorem here what I have a plus a bar dot b bar. So this function can be rewritten as a plus a bar plus a plus b bar. Is there any mistake? No. So the thing is what? But a plus a bar equal to 1. Is that correct? Is it correct or not? Yes, we have been realized, right? So that should be equal to a plus b bar. The thing is, what I understood, so this function should be equal to, it can be as this whole function can be replaced by a plus b bar, a plus b bar. But we have, on the top we have one more bar now. According to De Morgan's law, once again, a plus b whole bar can be written as, right? So if I take bar for this, if I take whole bar, what I will get, it will become a bar dot b double bar, getting cancelled now. So you are going to get what? It should be equal to a bar dot b. For this function, if you are getting a bar dot b, then for this function you are going to get what? A dot b bar. You can realize. That's your task, because I taught one thing and rest of things you can do, right? Let's see. Let us pass this input to this gate, last gate. Let's see what happens. Its output is, once again, what it will do? First, it will add the input. I am getting a bar b plus a b bar, and then it will take the complement for this. We all know one thing. What we all know, whenever we are taking, right? So the conclusion is, I understood one thing. If it is take complement for this, let me write that one. One second. Let us rub all these things, right? Now, what I have understood, since I have a NOR gate here, right? I have a NOR gate. So in this NOR gate, here I am getting a bar b plus here I am getting a b bar, and we should take whole bar. If I take whole bar for this one, what I will get? It will give you the value of, right? It should be equal to, definitely it will be equal to what? A bar b bar plus ab. Why? Did you notice one thing carefully? What is this? Which is equal to, right? Once again, which is equal to what? Let me write like this. It is equal to a XOR whole bar. Because a bar b plus a b bar is nothing but what? My XOR gate, right? But here, if I take whole complement, we are going to get X NOR gate. In order to visualize XOR gate, once again we have to pass it through one more gate, right? So let me rub this one. Okay, what I have to do? Let us rub these things. So if I pass this one through this one more gate, what I will get? Here we are visualizing a bar b, and here I am visualizing a b bar. Wait, that is a b bar, such that it is going to be a bar b plus a b whole bar. Again, if I pass it at this point, we are getting a bar b plus a b bar. If I pass it through one more NOR gate, you are going to get what? A bar. Once again, actually here we are getting whole complement for this, right? திரும்ப நீங்க இன்னொரு பார்லயே பாஸ் பண்ணீங்க அப்படினா what it will do? It will take double bar. இத திரும்ப நீங்க பாஸ் பண்ணீங்க அப்படினா we are going to get a bar b plus a b bar whole bar. On the top, what we are going to get? Actually, what will happen here? It will be doubled, right? இங்க என்ன நடக்கும் அப்படினா if I pass x here also going to be x. X plus x will become what? X only, right? Then whole bar. So நீங்க ரெண்டு ஃபங்க்ஷனை கன்சிடர் பண்ணி ஆட் பண்ணீங்க, again we are going to get one function only, but on the top we are going to consider one more bar. Here itself we have a bar. We are going to pass it right through the one more NOR gate, such that this double bar are going to be cancelled each other. So you can visualize the output is going to be what? A bar b plus a b bar, right? A bar b plus a b bar. So what is the conclusion here? We are going to get, if you want to decide where is your XOR gate, this is your XOR gate, right? And here you can visualize X NOR gate. We can visualize the effect of X NOR gate. Up X NOR gate listen, what happened here? I am getting same thing for both of these people. Actually, it will be inverse, right? Once again, guys, if it is 5, then it will become 4. If it is 4, it will become 5. I think I made somewhere mistake. Did anyone realize? Wait once again, I will check it. I don't know whether this one is wrong or this one is wrong. Let us check it once again. It is going to be a, and here it is going to be a plus b whole bar. So, yeah, that is correct. Then this become a plus b whole bar. Yeah, that is correct only. And this can be visualized as a plus a bar dot b bar. That function can be written as a plus a bar, that is equal to 1. Then we can write a plus b whole bar, and then we have to construct whole bar. That is going to be a bar dot b, that is correct. And here we are going to consider a b bar, that is also correct. If I pass it through this one, then it will become complement, then I am going to get X naught. This is correct. I think in the NAND operation I made mistake, right? Anyway, let us conclude first. For XOR gate, how many gates should be required here? 1, 2, 3, 4, 5, right? So in order to perform XOR gate, it is required 5 gates. Similarly, if you want to perform XNOR gate, see that here itself we are visualizing the output of XNOR gate. So that it should be required 4. Listen, NAND and NOR, the relation will become opposite, right? Opposite is but somewhere I think I made mistake, right? And I forgot to design one more gate. You can design it by yourself. Anyway, let me conclude. Let us design NAND gate also, and then I will realize this one. Somewhere I made mistake, I think, right? Let's check it. Anyway, first we have to design NAND gate from NOR gate. If you want to design NAND gate from NOR gate, how will you design? Let's see. In order to design NAND gate, once again, the thing we need to do is, what I am going to do now? Let us design NAND gate. If you want to design NAND gate, once again, let us see. Let us visualize. This is going to be NOR gate. Yes. Let us consider its input is A, and second, it is going to be B, right? And let us see. I am passing it through this gate. One more gate I am considering here. Let us see what happens here. If I am looking for NAND gate, what will happen? Its output is what? Here we are going to get A bar, right? And here we are going to get B bar. If I pass it through this gate, you are going to get A bar plus B bar whole bar. Actually, it is equal to what? It is equal to, we all know, that is according to De Morgan's law, A plus B whole bar can be written as A bar dot B bar, such that double bar getting cancelled. So our output is going to be A dot B, right? A dot B. Now let us see. Now I will pass it through the gate, one more gate. See, that is AND gate. AND gate we design AND gate now, but we are looking for what? NAND gate. So if I pass it through one more NOR gate, such that you can visualize, we can realize the NAND gate, right? Let us see. AB, it is also become AB, and this is also going to be AB, such that output of this function is going to be AB plus AB, and then it will become AB whole bar. But what we all know, the thing is, AB plus AB will become AB only, so it can be written as AB bar. That is how we are realizing NAND gate. In order to design NAND gate, I am in need of 4 gates. Clear? So everything is perfect. Let me give you one small task. Let us check, right? XOR NOR gate is correct. Realize your NAND gate. For XOR it may be required 4. For XNOR it may be required 5. And the operation, I think somewhere I made mistake. Please correct it by yourself. Group la post panunga, then I will check it, right? Let me correct it, but I don't want to waste my time, right? Because we are closing 6. We are getting close to 6. Sorry for the disturbance. Some people are interrupting me. Fine. So that is how we are realizing various logic gates, right? I hope things are very clear to all. Guys, one small task. Just take your XOR gate and XNOR gate, realize it with the help of NAND gate once again, right? Cross check it by yourself. Let me correct it. That's all. Clear? So this is all about basics of logic gates. It's completely over, right? Now next thing is we have to design the switching circuits. Switching circuits in the sense, logic gates use we have to design the switches. Like we can say like this. Sir, I have what I can say. We have 2 switches like AND gates are reclam. We can take a transistor. With the help of transistor, we can design the AND operation, NOT operation, NOR gate and all. Actually, you know one thing. Switches are acting as a AND gate, OR gate, NOT gate. This design I said in power electronics at all, we are realizing these things in terms of electrical values like electrical voltage, electrical current, like that, and electrical power. So in digital electronics, what we are going to do in terms of binary, we are defining all those things. Clear? Oh, let us see. Tomorrow in the next class, we will take the switches and we will see how to perform the same operations with the help of diodes, transistor. Then you will come to know what is the relations between analog electronics and digital electronics, right? With this, let's wind up the class. If you have any other doubts, you can ask in the group, right? Thank you all.